my people, welcome to the channel. In this video we are going to learn about Boyle's law. And Boyle's law, this is a law that describes the behavior of gases under several conditions. What are the objectives of this video? So by the end of this video you should be able to 1. State the Boyle's law, 2. Describe the law mathematically and graphically, 3. Use Boyle's law to solve numerical problems. Okay, let us start by stating Boyle's law. Boyle's law states that the volume of a fixed mass of gas is inversely proportional to the pressure at a constant temperature. So that is how we state Boyle's law, and we can describe that law mathematically. From the law, we can deduce a formula whereby volume is inversely proportional to the pressure. Volume is inversely proportional to pressure. If you want to remove the sign of proportionality, you'll come and say volume equals to, we must introduce a constant, whereby constant is K equals to 1 over pressure. If you want to make K the subject of the formula, it will be Vp equals to constant. From the law, it means that when the volume changes from V1 to V2, pressure will as well change from P1 to P2. So from there, we can come up with an equation or general equation whereby V1 P1 equals to P2 V2. This is a general equation for the Boyle's law. If you want to solve any numerical problem, we can just use the formula to solve it. So we can as well express Boyle's law graphically, whereby if we plot a graph of volume against pressure, we plot a graph of volume against pressure, the graph will be a curve. That means when volume decreases, the pressure increases, and when the pressure decreases, the volume increases. And as well, we can plot a graph of volume against the reciprocal of what? Of pressure. So if we plot a graph of volume against what? The reciprocal of pressure, the graph will be a straight line. So basically, that's how we can describe or express Boyle's law graphically. Let us see if we can use the formula to solve a numerical problem. So this one has a volume of 25 cubic centimeters. Calculate its volume if the pressure is doubled. Now from the graph, we learn that when the pressure is doubled, the volume would be halved. If the pressure is halved, the volume will be doubled, since that the volume is inversely proportional to its pressure. Let us see. We will employ the formula V1 P1 equals to V2 P2. So which is our V1? It is 25 cubic centimeters. V2 we don't have. P1 is what? That one. P2, we've been told that the pressure is double. It is this one multiplied by 2. It will be Pascal. If we have the values, can we be able to calculate the volume? Yes. I'll take the formula and substitute with the values. You can use the formula to calculate the volume, whereby V1 is 25 cubic centimeters multiplied by P1 Pascal equals to V2, which we don't have, multiplied by what? P2. Now we want to calculate the value of V2. How shall we go about it? About this? So I'll divide this side by value of V2, and the other side by the same value of pressure. So V2 will be 25 cubic centimeters multiplied by pressure divided by if you work out that, what we'll get is 12.5 cubic centimeters. So that is the value of what? Volume 2. It's my hope at that point it is well understood. Let me give you an exercise so that you can try. That is a question that you're going to try. And don't forget to give me your answer in the comment section below. And in case of any question, don't hesitate to ask. Put your question in the comment section and I'll get back to it. Thank you for watching. I hope it has been a wonderful class. Let us meet in the next video, but don't forget to like, subscribe, and share the video. Bye bye.